Everyone, my name is Fisker-Bødker, and I'm a PhD researcher at the Technical University of Denmark, also called DTU. I want to show you my second setup where I do studies on battery electrolyte. I made a tiny robot out of frustration because my previous robot that I've shown you uses some very expensive syringe pumps, and they came with a lot of faulty firmware. And eventually I ended up building my own robot.
A battery is made of three things. Roughly said, your plus, your minus, and the electrolyte. Electrolyte is the gel you find inside modern batteries, and it separates the electrodes. If we want to use more common metals than cobalt and lithium, we need to find new good electrolytes. During a busy cold winter morning, you don't want to come out to your car and discover that the battery is frozen. You don't want your cell phone battery to catch fire if it's lying in your pocket on a warm summer day. Therefore, the electrolytes needs to be tested for many things.
I mix different components for battery electrolyte. I can then test them at different temperatures and their conductivity, and eventually I use an AI to optimize the mixture of the battery electrolyte. Right now we're testing for zinc batteries, but this is also done in a glove box over here for lithium and sodium batteries and so on.
The robot aspirates different liquids into plastic syringes and dispenses it into a mixer. The mixer is basically just a PWM-controlled computer fan with magnets attached on top. The magnetic stirrer in the vial then ensures everything is mixed, even if it's like honey. A peristaltic pump transports the mix into a test cell. The test cell allows us to put power to it, while keeping it completely stable at 25 degrees Celsius. Here we find the conductivity of the electrolyte. After testing, another peristaltic pump transfers the liquid into the next test cell, where the temperature varies from -30 to +60 degrees Celsius, and the stability window and transverse number is found. As you can see, I used very cheap components all in all, and it works great. So I use Arduino, off-the-shelf stepper motor drivers. I use stepper motors to move the syringe pumps, and off-the-shelf boards for controlling the servo motors, relays, what I could find in what is probably similar to Home Depot, and to connect all the cables. Fuse. Here this is my temperature control, controlling Peltier elements and so on. I use a tap beer cooler to pre-cool the coolant before it goes to the test cells. And this has given the robot the nickname BeerBot. The cheapest and quickest steel container I could come up with was a pot from IKEA and some construction foam. And it actually works great, to be honest. I hope I can inspire you to move quickly forward, avoid a lot of trouble, and get new ideas for your own self-driving lab. And keep track on me. I'll post other videos on how I do stuff. Bye!